This is January 05 question 4. State Newton's third law of motion. And this is they don't accept action and reaction are equal and opposite, which you may have heard a few times before. They're looking for if body A exerts a force on body B, then B exerts an equal but opposite force. On A. Choose a suitable example to illustrate the third law. Explain how the law applies to your chosen example. So you should always have a wee example in your head for Newton's third law. And Newton's third law involves forces which are equal, opposite, acting on two different bodies, and they're the same type. So that's it written over at the side there. So you think of an example that you could give a good description of. And probably the man standing on the earth is probably one of the best descriptions. So the man standing on the earth, and therefore the earth is attracting the man with a gravitational force downwards, but the man's also pulling the earth up with a gravitational force upwards. And that's what you have to describe. So, e.g., man standing on earth, and then you're going to say the earth pulls man down, with a gravitational force, and man, so you just swap this round, swap the two things and swap the direction. The man pulls earth and it's up with a gravitational force. And again, there's quality of written communication mark here, so you would have to write that in a decent sentence. So there's the things that have swapped there. The earth and the man and the earth there too, and down and up. If you're talking about a book on a table, just be careful, because the book on the table, you have to always talk about reaction forces whenever you talk about the book on the table. If you have a book on the table, then you've got a reaction force upward from the table on the book, but you also have got a reaction force downwards of the book on the table. So you just need to be very careful that you're always talking about a reaction force. Because if you start talking about weight, you're talking about the earth on the book rather than the table on the book. This is question 4b from June 2004. January 2005. And again, it is very similar to the one about the car and the ramp. So this is a person standing on a skateboard at the top of a rough sloping track. The total mass of the rider and the skateboard is 73 kilograms. The track slopes at an angle of 9.5 degrees to the horizontal. The rider and the skateboard start from rest and move down the track with uniform acceleration of 0.46 metres per second squared. During motion, the force of friction in the board is constant and air resistance is negligible. Figure 4.1 shows a simplified diagram of the situation in which the rider and skateboard have been replaced by a point mass in contact with the track. Calculate the magnitude of the resultant force causing the skateboard and rider to accelerate down the slope. So you need a resultant force, and you've been given an acceleration in the question and a mass. So that's just very straightforward, F equals ma. And that's equal to 73 times 0.46. And that gives you 33.58, or to three significant figures, that's 33.6 newtons. Calculate also the constant frictional force acting on the skateboard as it moves down the slope. Now this is where you have to start resolving the weight and then working out what the frictional force is. So if I just scan in a wee bit so you can see that a wee bit better. When we resolve the weight, as usual, what we do is we draw a right angle triangle, and this component is always at right angles to the slope. So right angle triangle, that is your 9.5 degrees. And then this is a weight here, and And so this is a component of the weight, and it's the one with sine in it, so it's W sine 9.5 degrees. So therefore, what you're saying is if that's accelerating down the slope, if I draw a wee red arrow above it, oh, it's there already, that means that this force here must be greater than that force there. And the resultant force is that, take away that. And that then is equal to that's equal to the resultant force you calculated in the question above. So I'm just going to do that here then. So if we just look at it again, it's this, take away that. So W sine 9.5 minus F, that's your resultant force, and then that's equal to the 33.6 you calculated in the last question. So W sine, W then is going to be 73 times 9.81, and that's multiplied by the sine of 9.5. Take away F equals 33.6. And that's 118.2 newtons, and so we subtract 33.6 to get F. And F comes out to be 84.6 newtons.